All right, Wildcats, here we are. Chapter 2, Lesson 2, Rivers. Okay, I have this page here to help me remember the format. You need a piece of paper folded in half down the center. You obviously need your pencil, and then you need red and blue, either pens or colored pencils or crayons to underline highlight after the fact. Okay, go get all your materials, pause this video, and then when you have all your materials, come back and let's get started. First thing is the same. Write my name. I'm writing my name. You write your name. Don't write my name. It's not yours. Today's date. I have to look at the clock real quick. September 28th. So 9/28/2020. Class or period, AVID 6. Capital A, capital V, capital I, capital D. Number 6. Okay, topic or objective. We are doing science, capital SCIENCE. FNT, capital F, capital N, capital T. Phase, capital PHASE. 2. We're now on phase 2. Colon. Process, capital PROCESS. Main idea or essential question. Water running downhill is a powerful force in changing Earth's landscape. Rivers erode, move sediment, change course, and flood their banks in a continuous pattern. Okay, so let's use our blue. Main idea, capital MAIN. Idea, capital IDEA. Slash, capital E period, capital Q period for essential question. We're going to do it in notes style. Let's see. Water running downhill. Water, WATER. Run, RUNS. Water runs downhill, DOWNHILL. Equals powerful, POWER for power, FUL for full, powerful. Water runs downhill equals powerful force, FORCE. Arrow changes, CHANGES. Landscape, LANDSCAPE. We will put a period so that we know there's two thoughts here. So water runs downhill, and that's a powerful force that changes our landscape. Rivers, RIVERS. Notice I'm not doing capitals because I don't want myself to think that these are complete sentences. I want myself to realize these are just notes. Rivers erode, ERODE. We remember from our last time that erosion or erode means to carry sediment away. Move sediment. Well, wait a minute. Erode is moving sediment. We're not going to write that. Change course. Change, CHANGE. Course, COURSE. That means that they can change direction, right? They wind and they bend and they turn following the landscape. Comma, flood, FLOOD. They flood their banks in a continuous pattern. So rivers erode, change course, flood, arrow, continuous, CONTIN, continuous, OUS. Continuous pattern. We can squeeze it in there. PATTERN. And then let's put a period. So water runs downhill, and that's a powerful force that changes the landscape. Rivers erode, which we know means carrying sediment away. They can change course, so they can move left and right and bend and wind. And they can flood, and they do all those things in a continuous pattern. All right, red pen or pencil? Oh, wait, nope, just kidding. Vocabulary. Vocabulary. Okay, let's go back to our pencil. First vocabulary, alluvial fan. Alluvial fan. ALL. UVIAL, alluvial fan, FAN. That's on page 61. There's 59. There's 61. There's alluvial fan. An alluvial fan is a fan-shaped landmass that forms after water rushes down a steep slope, then slows over a flat plain. This is a picture of an alluvial fan. So what that means is water was running downhill. It erodes or carries away all that dirt. It goes down the steep slope very fast, and then when it gets out to this flat ground, it kind of fans out and spreads out very smoothly. So that's what an alluvial fan is. Okay? It's important that it's a fan shape. It's important that it's a steep slope, and then it slows. Okay, so alluvial fan. Fan shape, F-A-N dash S-H-A-P-E, fan shape, equals water, W-A-T-E-R, rush, R-U-S-H, downhill, we're going to indent, leave some space, just D, O-W-N-H-I-L-L, so water, rush, downhill, arrow, slow, flat, F-L-A-T. So fan shape equals water rush, downhill, arrow, slow, flat. So what we can tell ourselves is an alluvial fan is a fan-shaped landform that forms by water rushing downhill very quickly, and then it slows down when it gets to the flat part, and it fans out in that fan shape. Let's do this. Water rush quickly, Q-U-I-C-K-L-Y. So water rushes quickly downhill, and then it slows down when it gets to the flat spot. Okay, water rushes downhill quickly, and then slows down when it gets to the flat spot, and it fans out. Okay, next, delta. Delta, and it says page 61. Delta, D-E-L-T-A, delta. A delta is a low plain that forms where a river enters the ocean. Okay, low plain, river enters ocean. Low plain, P-L-A-I-N, comma, river, arrow, ocean, O-C-E-A-N. So a delta is a low plain where the river enters the ocean. Okay, we know that a low plain is a low area that's flat, so it's low elevation, and then it's very flat, and so that's where the river enters the ocean. Okay, here is an example. A river in Mississippi has this very flat land all around it, and it flows out, and then it spreads. See all these little branches that spread out and flow into the ocean? That is the Mississippi River Delta. Okay, another little trick. Delta in math is like a triangle. Okay, we're going to draw that little triangle. Well, here comes the river, and then it spreads out kind of in a triangle pattern. Notice that the alluvial fan is almost like that pattern. Like if that's the point, there is almost like a little bit of a triangle shape in that semicircle. Same thing for the delta. It comes in at a point, and then it spreads out in all those different directions like a fan or like a triangle. Same thing here. It comes in, and then it spreads out in that triangular or fan shape. All right, our next vocabulary term, deposition. Deposition. Notice the word deposit is in deposition. Deposit, to put something down, or like deposit money in the bank. So let's go look at deposition. Go back to the beginning of the sentence. The process of dropping sediments is called deposition. And you can see they're trying to help you with that here. Dep-a-zish-un. Deposition. Okay, deposition. D-E-P, dep. O-S-I-T for deposit. But then I-O-N changes it to deposition. Dropping, D-R-O-P, and actually let's just leave it at drop. Drop sediment, S-E-D-I-M-E-N-T. That sounds very similar to another word we know. doesn't it? Sounds very similar to erode. Erode carries it away, so let's put erode. And then when it finds its home and it gets deposited, that's deposition. So erode, arrow, deposit. Sediment gets eroded, and then it finds a home, and that's where it is deposited, or deposition happens. Okay, next word. Meander, page 60. There's page 60. Page 60. Meanders, meanders, meanders. M-E, me, A-N-D, and E-R-S, meanders. Going backwards to the beginning, meanders and oxbow lakes. When a river moves across wide, flat regions, it begins to wind in curves called meanders. Okay, that's what's happening in this picture. Rather than flowing straight down, like straight down a very steep hill, when the land is very flat, the river actually starts to carve out curves over time. Those are the meanders. So, wide, flat region, wind curves. Wide, W-I-D-E, comma, flat, F-L-A-T, region, R-E-G-I-O-N, arrow, winding, W-I-N-D-I-N-G, curves, C-U-R-V-E-S. I'm actually going to erase that little comma right there because I don't want to think that it's two separate notes. So meanders happen when there's a wide flat region and the river starts to curve in winding curves. Next word, and the last one, tributary. It's on this page, tributary. Notice the word tribute in tributary, kind of like contribute, like I give something or I contribute to the discussion. Okay, tributaries, T-R-I-B-U-T-A-R-I-E-S, tributaries. Most large rivers are joined by many tributaries, which are streams and small rivers that join a large river. This is a perfect example. Okay, here's the ocean out here. Here is the mouth of the river, and you can see the little delta forming. The winding curves and the meanders of the river in the flat floodplain. But all the way back here in the hills and mountains, there were tiny little streams and creeks that all came together and contributed to this larger river. So they are tributaries. Okay, let's see. Many tributaries. Streams, small rivers join a large river. Okay, tributaries. Streams, S-T-R-E-A-M-S, and down, 3 down. Creeks, C-R-E-E-K-S. Arrow, larger, L-A-R-G-E-R. Rivers, R-I-V-E-R-S. So streams and creeks come together to form larger rivers. Those are tributaries. All right, now we can get our red and do our title. How rivers form. Capital H-O-W, how. Notice that I'm skipping a line in between to leave some space. Rivers, capital R-I-V-E-R-S. We are already more than halfway down our page. Form, capital F-O-R-M. Switch back to our pencil. Rivers typically begin high in the mountains. Water collects as runoff, which is rainwater or melting snow that flows over the ground. Because of gravity, the runoff flows downhill, gathering first into tiny trickles, then into brooks and streams. Further downhill, streams join other streams, eventually forming a large body of flowing fresh water, a river. Most large rivers are joined by many tributaries, which are streams and small rivers that join a large river. Okay, so we need to say begin in mountains, right? Begin, B-E-G-I-N, N-I-N, mountains, M-O-U-N-T, A-I-N-S, slash hills, H-I-L-L-S. So in other words, they start up high. Runoff, it can be rainwater and melting snow. So runoff, R-U-N-O-F-F. All that water that's flowing down out of the mountains is considered a runoff. Runoff. equals rain, R-A-I-N, plus melting, M-E-L-T-I-N-G, snow, S-N-O-W. Okay, we know that gravity makes it flow downhill. And now we know about the brooks and the streams and the tributaries, right? So let's see. Let's go ahead and use that word, tributaries, T-R-I-B-U-T-A-R-I-E-S, arrow, river, R-I-V-E-R. So rivers begin in mountains and hills at a higher elevation. The runoff could be rain, or it could also be melting snow. Tributaries collect to form larger rivers, just like we said there. Okay, next paragraph. Rivers will take the shortest and steepest path downhill. Sometimes stretches of whitewater or waterfalls form part of a river's course. So whitewater is just when the water is rushing very fast and crashing against rocks, and it looks very rough. Sometimes you see pictures of people riding in rafts with life vests on going down the White Rapids. Sometimes a river's course changes direction because huge boulders or other obstacles block the most direct path. All rivers ultimately empty into large bodies of water, such as lakes or the ocean. So you could imagine if there was a giant earthquake and a huge boulder fell down and crashed into this rock or into this river or stream, that would change the course of the river. Okay, so they take the shortest, steepest path. Take, T-A-K-E, shortest, S-H-O-R-T-E-S-T, shortest, steepest, S-T-E-E-P-E-S-T, steepest, path, P-A-T-H. Take shortest, steepest path. And then courses can change, right? Course, C-O-U-R-S-E, changes, C-H-A-N-G-E-S, arrow, lake, L-A-K-E, slash, ocean, O-C-E-A-N. So a river's course can change, but it always ends up in either a lake or an ocean. All right, next. With a length of 615 kilometers, that's 382 miles, that's about the distance from here in Wasco to Stockton or maybe even San Francisco. The Sacramento River is the longest in California. From its source near Mount Shasta, it flows through the northern part of the Central Valley before it empties into San Francisco Bay. Okay, so they're telling us the Sacramento River goes all the way from Mount Shasta, way up in the mountains, all the way out to San Francisco where the ocean is. As a stream or river moves downhill, its rushing water weathers and erodes the ground over which it flows. So it's breaking up rock and bits of sand and dirt, and then it's carrying them away. It's carrying all that sediment away, which will eventually be deposited in the delta. Bedrock is broken down and minerals dissolved. Soil, pebbles, and other sediment are picked up and transported by the river. Over time, the river carves out a wider and deeper channel. All right, so let's see. We know about weathering and erosion. We know about breaking down bedrock, and we know about minerals dissolving. We know about sediment being picked up and transported. Let's say that over time, the river carves out a wider, deeper channel. Wider, W-I-D-E-R, / deeper, D-E-E-P-E-R, over, O-V-E-R, time, T-I-M-E. So rivers get wider and deeper over time. As the flow of water increases, the moving water and rocks carried by it further erode the riverbed. Okay, so that's basically saying the same thing. As more and more water flows, the rocks and sediment further erode. In other words, it gets wider and deeper over time. Sediment is carried away from the riverbank. A river valley forms. Okay, we've talked about river valleys, and this looks like a river valley. Sometimes rapid cutting of the valley floor in the upper part of a river creates a canyon. So if a lot of water flows here very quickly over the course of even a year or 5 or 10 years, it can erode and carve out a canyon so fast that then it starts to eventually look like the Grand Canyon, where the walls are flatter and steeper than even a river valley. The amount of sediment carried by a river is called the sediment load. The larger and faster a river, the greater its sediment load. A faster river has more energy than a slow river, so it can carry more sediment and bigger pieces of sediment. Okay, that makes sense. So the faster the water is flowing and the more water there is, it can carry away like larger rocks and pebbles rather than just little tiny bits of sand and, almost like microscopic bits of dirt. Okay, so let's talk about sediment load. Amount, A-M-O-U-N-T, of sediment, S-E-D-I-M-E-N-T, equals, quote, load, L-O-A-D, end quotes. So the amount of sediment that a river carries away is called the load. All right, let's look at our pictures. Okay, tributaries, floodplain, mouth and ocean. That is the river. Those curves are meanders. That little area is actually a delta. They do not show an alluvial fan on here because we haven't gotten there yet. Okay, up here, a mountain stream in California weathers rocks as it rushes over them. It carries sediment downstream. So they're just showing a picture of how the river flows downhill, and you can see little bits where the water is white. That means it's rushing quickly and hitting large rocks. Okay, now this one's pretty small compared to this one, so the bottom picture has a higher load. The top picture has a smaller load. Over time, some rivers create the deep V-shaped valleys known as canyons. So instead of just a V-shaped river valley, this is now becoming a canyon. What path does a river usually follow? Let's see if we can answer that from our notes. Okay, a river usually follows the shortest, steepest path. For example, tributaries in the mountains and hills collect and come together to form a river. And then as the runoff flows downhill, the course of the river can change, but it always ends up in a lake or an ocean. The rivers get wider and deeper over time, and then that's it. That's all about the path. The load doesn't really talk much about the path, so we don't need to talk about that. Okay, we can answer that question with our notes, so that means we're done. That's it for our first day. Good job persevering with a growth mindset, and roar Wildcats!